Moving on to number 18. Calculate the pH, the pOH of each of the following solutions at 25 degrees for which the substances ionize completely. Okay, so let's take a look at that. The first one is hydrochloric acid, 0.20 molar. Hydrochloric acid, 0.200 molar. This tells you that the hydrogen ion concentration is equal to 0.200 because this ionizes completely, okay? So the question is, again, the pH. So the pH of that would be the negative log of this hydrogen ion concentration. If you put 0.2 in your calculator and do log to the base 10, you get the log to the base 10 of this is equal to minus 0.6, well, it's basically minus 7.00. And then it's the negative log, so it's 0.700. So the pH of this first solution is 0.700. The second part of this question is pOH. There's two ways you can do the pOH. The easy way is to just subtract 0.7 from 14, or 13.3. The other way you can do that is you go back up here and you put 0.2. You remember that the 1 times 10 to the minus 14 is equal to the hydrogen ion concentration times the OH ion concentration, and you put 0.2 in here and then X here and solve for X. And then whatever answer you get there, if you do that, if you put 1 times 10 to the minus 14 and divide that by 0.2, you get 5 times 10 to the minus 14. And if you then take the negative log of that, you get, again, 13.3. So you can either subtract this from 14, or you can do this calculation and then find this is the OH ion concentration, and so if you do that, it gives you 13.3. Number 2, or B, excuse me, is a fairly straightforward one. So let's go down to D. D's a little bit more difficult. D says that you have a 0.0031 molar solution of calcium hydroxide. Okay, now the reason I say this is a little more challenging is if you look at it, calcium hydroxide ionizes to form a single calcium ion and 2 hydroxide ions. Therefore, the concentration here is going to be 2 times 0.0031, or 0.0062. And that concentration is what you would use. That would be your OH ion concentration. So that would be what you would use to calculate your pOH. So your pOH is going to be, again, the negative log of 0.0062, which is going to be 2.21. And again, if you subtract 14 from that, you get the pH, which is 11.79. So in D, the pH is 2.21, the pOH is 2.21, the pH is 11.79. Now that's assuming complete ionization, which is what the question says. Now it's very important to remember that we will be doing problems in the future where this ionization is not complete. The next problem is problem number 21, which states What are the hydronium and hydroxide ion concentrations in a solution whose pH is 6.52? Okay, the pH is 6.52. Remember that I set that you can immediately say the pOH is going to be subtracting this 7.48. Remember that I said that the hydrogen ion concentration, and this comes from that table in your book, is equal to 10 to the minus whatever the pH is. So you put 6.52 in there. So what is that number? Well, your calculator has a function which is x to the n, okay? Or the inverse log. And so if you don't know how to do that, you can ask your parents to help you with that. Actually, there's a function on my calculator that has 10 to the x, and you just put x in there. So you put 6.52, and it's a negative. Push your 10 to the x button, and it's 3.01 times 10 to the minus 7. 3.01 times 10 to the minus 7. And then the OH concentration is the same thing, 10 to the minus 7.48. So you put 7.48, and it's 3.31 times 10 to the minus 8. Now to check your answer, if you multiply these two numbers together, you should get 1 times 10 to the minus 14. And if you don't get that, then you made a mistake. Because remember that pH times the pOH has to always equal 1 times 10 to the minus 14. Okay. Now, these next set of problems, all the problems we did up to this point, take it into the idea that the acid or the base that we're working with is a strong acid or a strong base, meaning that it's either completely ionized or we're assuming that it's completely ionized. Starting with this group of problems, we're going to be talking about substances that do not necessarily completely ionize. And so we'll be working with specific equilibrium constants for acids called Ka and for bases called Kb. So when we're working with this kind of problem, we're working in a situation where the ionization is not necessarily the same for all. So let's take a look at number 40. Predict which of the following pairs is stronger and explain your reasoning for each. Okay, the basic principle behind these has to do with the effect of electronegativity on the strength of an acid or a base. When something is very electronegative, so for example, if you have a combination of hydrogen and fluoride, which is the in the first one here, hydrogen and fluoride versus hydrogen and oxygen. Okay, when something is very electronegative, it, as you remember, it holds on to vigorously the electron that it steals. So that means that this is more likely to donate a proton because this species grabs the electron more vigorously than this species does. So when you compare these two, the electrons are grabbed more vigorously by hydrogen, therefore releasing a proton more easily than the electrons being grabbed by oxygen. And so this hydrogen is much less likely to be released than this hydrogen. And so therefore this is the strongest in this combination right here. If you look at the next one, you have a comparison of B, boron, versus aluminum in the same setting. So if you think about that for just a second, and if you need to stop the tape to think about it, that's fine. But if you think about it, B on the periodic table is farther up than aluminum. Therefore, it has, again, greater electronegativity than aluminum. So it is going to grab the available proton or electrons, and therefore it will cause a stronger compared to aluminum. So in this case, it would be a stronger base because it's releasing hydroxide than aluminum. For C, you have HSO4 and HSO3. Now this may not be as readily available or readily obvious, but what you have to do is look at the oxidation state for sulfur in these two settings. Here it's +6, and here it's +4. Now, as it turns out, the greater the oxidation state, the increased the acidity. So this means that the greater the oxidation state in this setting, this is stronger than this because this has a higher oxidation state than this. The fourth one, which is ammonia versus H2S or sulfur dioxide. Now, the way you would delineate those two is that fact that ammonia actually takes a proton to form ammonium ion. That's its most natural step, whereas sulfur releases a proton, and that's its most natural state. And so this would be a stronger acid, obviously, and this would be a stronger base. And so in this setting, based on this problem, ammonia as an acid is weaker than sulfur dioxide, and that sulfur dioxide, if you were talking in terms of a base, would be a weaker base than than ammonia. So the last one is water versus H2TE. Now what we have to do is compare O to TE. And TE is in the same group, 6A group that O is in, but it's lower, and therefore the acid forming groups in the same area, that is, if you have two things in a 6A element, see if I can explain this right. You have O is up here, TE is down here. The heavier molecules form stronger acids compared to the lighter. Heavier is stronger than lighter. The next problem we're going to work on, and the last one for this part, is problem number 48. Now, problem number 48 says the following. Which of the following will increase the percent of ammonia that is converted to the ammonium ion in water? Now, this is actually an equilibrium constant question, a Le Chatelier's principal question, as opposed to the, but let's take a look at it anyway. So we want to know if you have the following equation, ammonia plus water goes to form the ammonium ion. We're doing 46 here. Goes to form the ammonium ion plus the hydroxide ion. Okay, so which of the following This is 48, I'm sorry. Which of the following, if it's added, will favor the formation? Which of the following, if it's added, will favor will increase the percentage of NH3 that's converted? So it will cause, which of the following added will decrease this and increase this? So which of the following A, B, and C will drive the reaction from this side to this side, or to the right? So if we look at the first one, the addition of NaOH. Well, if you add NaOH, what are you really adding? You're adding OH ions. And if you add OH ions, that drives the reaction this direction. So that's no. That doesn't increase the percentage. Number B, if you add HCl, what are you adding? You're adding hydrogen ions. Well, if you add hydrogen ions, what happens? Well, what happens is this hydrogen ion will react with this OH to form water. So it increases the amount of water. If you increase the amount of water, it drives the reaction to the right. So this is a yes. C. If you add NH4Cl, well, NH4Cl adds NH4 ions. So that has the same effect. That has the same effect as adding NH4 here, which drives the reaction in this direction. So that's a no. So the only thing that increases the production of NH4 and the reduction of NH3 is this middle one. The last question, we are going to stop at this point and go on to part 3.